discuss question based on Mera. So now let us attempt this question. Question number 7. Try this one. So I will give you. Are you trying it?
Yes.
Here you have to apply the formula. Let us see. It says you are asked to design. The question says you are asked to design a shaving mirror. So we know that which kind of mirror is used for shaving mirror? Concave mirror, right?
Yes.
So here person keeps 10 centimeter. It means u is given as this is 10 centimeter, and view a magnified image of the face. So this is v. So now you have to apply mirror formula. If you calculate focal length, then we will calculate radius of curvature. This is it. And t is obviously minus 25. And f from here we get 1 by that is t 5 by 250. So from here we will get f is 2. Now the radius of curvature of, so r should be equal to 2f. F means minus 100 by 7. So approximately minus 40. So no option matches with it, but if you see the closest option is 24 or 5 cent. Mistake in the, maybe there is a mistake in the question. They have applied the same formula 5 weeks, 5 minus 10, 10 minus 25, 35 by. So I think there is a mistake in the data, but the method will be same, right? To find the radius of curvature, so the closest option, there is no option which is matches with the 40. The mark the closest, but is still not correct answer. I think there is a mistake in the data, maybe, but the method will be same, right? Now solve this question number 11.
Option B.
What option? B. So the question says, short linear object of length B lies along the axis of a concave mirror focal length f at a distance u from the pole of the mirror. The size of the image is approximate. Here we have to find the size of the image. So by the mirror formula, the b plus 1 by b is equal to 1 by f. So now what we can do, we can also differentiate it. So we know that what is magnification. Uh, so we can apply the two methods. The first method, which we have learned in the last class, like we have a concave mirror and the object is of length b at a distance u. So we have to find the size of the image. So let's try method one. What we can do, we can apply this formula 1 by v plus 1 by u squared to f, and so, so we can apply the formula for both the terms, like for b 1 by b minus what will be the 1 by u will be equal to same image length object length to focal length. Sorry, the focal length of the mirror is given as f. We can put it minus f. So from here we will get b 1 by b. You can say b 1 by b is equal to 1 by u. Again, now we can apply the formula for and a. For a, what we can write? We can write 1 by v plus 1 by u equal to 1 by f. So here 1 by v, what will be? Minus u plus v, right? Length of the, that will be minus 1 by, here we will get 1 by v a. The v that will be equal to by u plus v. From here we can get 1 by v a will be equal to u plus v square, that is f minus. So from here we will get va, that is equal to u plus v to f by f minus u. Similarly, here we can also get Vb, that will be Vb to f by f minus. So now we can find Vb minus Va. So therefore Vb minus Va, that will be meaning Vb minus Va will be equal to is Vb to f by f minus 2. F by f minus 2 plus V plus Vf by f minus 2 minus 2u plus V divided by f minus u minus V, f minus. From here we can get f square minus u square f minus f minus f minus u plus divided by f minus. This is lengthy method, but I'm trying to show. I will show you both the method, or we can solve it short way, or we can. So from here you will get now. If you see, if I take uf as a common, so I will get it as f minus. If I take uf common, I will get f minus u. I get f, then we have already common f minus u. This we have to find the size of the image, right? Size of the image how if you see here that expression is basically small, so we can neglect b also. If I am neglecting b, like uf f minus b, this method is becoming lengthy, so let us try second method. I think we will get answer by this also, but square and all are coming here. The option method 2. This will be the method. Let us do it first. So here what we will do, we will use the method of differentiation. Since the object is small, so we can do the method of differentiation. So what we will do, we will write the mirror formula, we will differentiate it, and we can get the magnification. Then we can get the third. So for that, like we know the mirror formula, what is it? 1 by v plus 1 by u is equal to 1 by f. Now we can differentiate it, so we can write minus 1 by v square t minus 1 by u square t equal to 0. So from here what we can get, so from here we can get value of dv. dv will be equal to minus v square by u square t. And here dv will be basically change in length, so that will be the size of image, you can say, and du will be size of the object. So from here you can also write like d will be equal to size of the image, basically we have to find. So change in delta v and change in position of the image will be size of the image, right? So basically we have to find dv. So from here we can write it d by u square V upon U square P. So from here we can write by U square. Now basically du will be size of object, you can say, and final position is obviously will be less than the initial position. So you can also write dv equal to, you can also write like v by u square, and du will be equal to minus p, because the obviously the object distance or the change in object distance will be negative. So here from here you can also write dv will be equal to v into by v, sorry, v by u square, v by u square. So now we have to find v by u. If we can find v by u, then we can get the answer. So from here we can find the v by u. If you see here, what you can do, you can divide both sides by v, so you will get v by v plus v by u equal to v by f. So from here, or also you can divide it by u also, because we don't know v. So what we can do, we can also divide it by u. So we know the relation 1 by v plus 1 by u. So what you can do, you can divide by u both sides. So u by v with plus 1 will be equal to u by f. So from here you will get u by v is equal to u by f minus 1. So that is u minus f upon f. So from here you can get d by u will be equal to f by u minus f. So now you can get the, you can apply this formula, dv is equal to b into b by u square, right? So from here you can put the value b by u is equal to f by u minus f square. dv would be equal to this b into f by f minus, this will b into f by f minus u minus f square. Got it? You did the same way.
Yes.
So method 2 will be easier. We can also apply one more short method, that is here the relation between linear and lateral magnification. Linear magnification. This is how we can calculate. There is also relation. I don't think that relation between linear and their there is a relation between longitudinal and axial magnification. So actually the axial magnification is basically square of, from there you can also find. So basically what happens, relation between the linear magnification ML will be axial magnification MA is square of longitudinal magnification. Means it is, we know that the magnification is V by U, so it is V by U square, and axial means height of image or length of image, you can say. So length of image by length of object is V by U square. And from this formula, what we can calculate, V by U is this. See the previous formula, we got V by U is F by U minus F. You can directly put the formula F by U minus F, right? F by U minus F square. So from here you can directly calculate length of image, which is F by U minus F square, and length of LO is basically. In one line you can solve this question. You got it? So there is a relation that axial magnification is a square of linear magnification for a small object only. This is true for a small object only. So axial magnification means along the axis, the length of image by length of object is equal to square of linear magnification. From that relation also you can solve the question in one step. Understood? Got it, Amna? All right. Now we can start the question of refraction. So do you have idea of reflection from a plane surface? We apply Snell's law. I think you have the idea of Snell's law, and the basic idea, diffraction from plane surface. So here basically one thing, Snell's law becomes very important. The second thing is so, and you may have heard about like apparent depth. You know that if an observer is in rarer medium, and object is in denser medium, so the object appears close to the surface. So you have to multiply. If length is decreasing, you have to divide by mu. If length is increasing, you have to multiply by mu. This is the basic formula. So if like if observer is in denser medium, like if observer is in rarer medium and the object is in denser medium, suppose its depth is d, so it will appear closer to the surface and the formula will be given by d by mu, right? And if the observer is and if the object is in rarer medium at height h and observer is in denser medium, so it will appear at a greater height, which is given by mu h. So this concept, I think you know that. You have idea of this concept. So whenever object is in denser medium, it will appear closer and the apparent depth will be d by mu. And if the object is in rarer medium, so it will appear larger and we have to multiply by mu. Understood? So let us based on that, we can do some question based on refraction from plane surface. So can you try this question number 1? Maimuna, are you there?
Yes.
Try this question number 1. I will give you a hint for the question. What it says, a vessel of depth which is half filled with a liquid of refractive index of 2√2 and the upper half have another liquid of refractive index 2. The liquid are immiscible the apparent depth. So this question seems to be little difficult. Let us first do easy question, then we will attempt this one. Basic questions based on Most of the questions are based on total internal reflection and critical angle concept. First, we will discuss that, then we will explore the question. So the questions are from TII. Let us first we will discuss the concept of TIR. So let us give you first one example based on so suppose suppose a fish suppose a fish at a height of at a depth of 4 meters from the surface of the liquid. Most refractive index of the liquid is 4/3. So and suppose a bird moving so we have to find in the air we have to find apparent depth apparent depth of fish seen by bird. And the second is height of bird observed by fish. Suppose this height is 15 meters. So in first case, we have to calculate apparent depth of the fish observed by the bird, and in the second question, we have to find the apparent height of the bird observed by the fish. Are you getting the question?
Yes.
Try this. you got any answer?
No, sir. Dry. Sir, can you solve this because I'm getting confused?
Right. So what you have to find is one, if you see here, you have to find the apparent depth of the fish. So what will happen? This fish will appear closer to the surface to the bird. So for the first case, the apparent depth A will be equal to actual depth upon V. What is actual depth? 4 divided by 4 by 3. So 4 into 3 by 4. So it will be 3 meters. So to the bird, it will appear 3 meter below the surface. Understood? And height of the bird observed by the fish. So if the observer is in denser medium, obviously the outside objects will appear at greater heights. So the apparent height HA will be mu into actual height. Mu is 4 by 3 and actual height is 15. So it will appear as 20 meter. So to the fish, the bird will appear at 20-meter height from the surface, and to the bird, the fish will appear at a depth 3 meter below the surface. Got it?
Yes.
So this is how we should Now we have the concept of Snell's law. We know that V1 sin I. What is that? There is a surface and light ray is moving from one, and if refractive index is V1 for the first surface, V2 for the second one, and angle of incidence is I. Angle of So this concept we already have the concept of Snell's law. According to Snell's law, sin I to 2 sin. This is basically Snell's law. So now actually what happens, and we know that if light ray moves from rarer to denser, it bends toward the normal. If it is moving from denser to rarer medium, it moves away from. Now let us take the case when light ray is moving from denser to rarer medium. Right? Suppose this is a medium of refractive index mu, and light rays incident like this. What will happen actually? Will move away from the normal if angle of incidence is I. So suppose this is air, light ray is moving from denser to rare. So what will happen at some, if you increase more angle, it will move away and away from the surface. At a particular angle of incidence, it will move parallel to the surface. That angle is known as critical angle. So at I equal to IC, what happens? R becomes 90 degrees. You can apply that. Or you can also say IC equal to C, critical angle. So you can apply mu into sine C will be equal to 1 into sine 90 degree. So from here you can write sine C will be equal to sine 90 is obviously 1 by mu. So this we will get. Now what happens if you increase the angle further? If you increase the angle of incidence further, what will happen? Now it has no way, right? It has come to the boundary. So now it will return to the same medium. So this phenomenon is known as TIR, total internal. So for that, I should be, if angle of incidence is greater than critical angle, in that case, TIR takes. I think you have idea for this one, TIR. So now based on that, let us do some question. Almost the question, no straightforward question as generally asked. Most of the questions are based on TIR and all that. Let us now try this question number 4 based on TIR. So before that, let us try some basic questions and we will try 4. So let us try question number 8 first. So question number 8,
Okay, sir.
very basic question. Question based on need. Have you got any answer? What is your answer? Ramana, have you got any answer?
Sir, option D.
Yes, obviously it should be option D because the angle of incidence is equal to angle of what? Yes, the correct answer is option. Now to the question number 9. Very easy. Do it directly. Like which of the following is not due to total internal reflection? So we know that optical fiber is based on rays is also hot summer rays is based on billions of time. So I think B is the answer for 9. Right. What is the answer for question 9? Ramana, what is the answer for question 9? Should we be right? No, try question number 14. Try question number 14. So try this question. This is also based on TIR.
Okay, sir.
you try?
Sir, I got option B.
You got option B.
B.
Let me check. What we have to do here is suppose refractive index is rho. So with this point as A and this point as B. So for A, we can apply Snell's law and we will get sine 45 degree. 1 into sine 45 will be equal to mu into, suppose this angle is R, we'll get mu sine, right? So from here we will get mu sine R, that will be equal to 1 by root 2 equation. Now if you see the diagram, angle of incidence at this face, if this angle is R and so if this angle is R, so obviously this angle will be 90 minus R, right? So now at face B, if you see here at point B, at B, what we can write? We can write obviously 90 minus R should be greater than the critical angle, right? And then TIR can take place. So you can see R is less than T minus T. Sin R is less than sin 90 minus T. So from here and from one equation one you can write sin R is equal to 1 by root 2 mu, 1 by root 2 mu. So here we can write 1 by root 2 mu is less than sin 90 minus T is cos C. So it will be 1 minus sin square C. So we'll get it as 1 by root 2. You can equate also to find it. So 1 by root 2 will be 1 minus sin square C. So we know that sin C is 1 by mu. So it will be 1 by mu square. Now if you square both sides, what we will get? We will get 1 by 2 is equal to 1 by 1 minus mu square. By square both sides. So from here what we will get? Mu square is equal to 1 minus 1 by 2. Sorry, 1 by mu square. So that is 1 by 2. So mu square is equal to 2. So from here what we will get, and it is given that the index of the glass, I think there is some mistake here. So from here we are getting mu root 2. Obviously at B 90 minus R, what is R? 45. One by root. At B, we have to write T minus R should be. So R is less than 9. Cos C 1 minus 9 by root 2 mu. Oh, there is a mu here. We missed mu here. So we also have mu, right? So it will be 1 by 2 mu square. So we will also have mu square. It means we have 1 by 2 mu square is equal to 1 minus 1. So from here what we will get? 3 by 2 mu square is equal to 1. From here we will get mu square is equal to 3 by 2. We will get mu equal to 3 by 2. Correct answer should be A. How we got B? You understood now?
Yes.
It should be 3 by 2. So the main concept is what we have to do is we have to use the concept of TIR. If you see the crucial part was this one, we have to use this concept. Other concept we already know, so this was the crucial part. All right. Now attempt question number. Now we can attempt the J question. So this one here. So the same concept here. Now apply question number. Attempt question number 4. This is the same concept. Apply. Attempt it quickly. So here we have to apply the same concept as the previous concept. What it says here, the transparent cube of side D made of the material of the factor index mu2 immersed in a liquid of the factor index mu1. mu2 is greater than mu1. The right is incident on face AB at an angle theta shown in the figure. Total internal reflection takes place at point T on the face. So the theta must satisfy. So here you have to apply the same concept as the previous one, right? What you have to do is you will get here set at some angle R, so that will be 90 minus R, right? And 90 minus R should be greater than critical angle for TIR. And here what will be the critical angle? And from here what you can write? R should be less than 90 minus C. So sin R will be less than sin 90 minus C cos C. For calculation you can, so, and what will be the sin R? You can apply here Snell's law. So you can write mu1 sin theta will be equal to mu2 sin R. So from here you will get sin R equal mu1 sin theta by mu2, right? And that should be less than cos C, it means 1 minus sin square C. What is sin square? Sin C will be equal to mu2 y mu1. So 1 by mu2 y mu1, it means mu1 by mu2 square. So from here what we will get? Sin theta is, so from here you will get sin theta is less than mu2 by mu1 1 minus mu1 square 1 minus mu1 square by mu2 square. So if you take it common, you will get it as